This is paper 3H, calculator paper from practice test set 6 for the new Edexcel GCSE. Question 1, here is a rectangle. Rectangle has been divided into two strips, A and B, and the strips have the same width. So A is half of the rectangle and B is the other half of the rectangle. 2/5 of strip A is shaded and 5/8 of strip B is shaded. The length of the rectangle is 40 centimeters. What fraction of the rectangle is not shaded? And it's asking what fraction is not shaded. So for me, I see that 40 centimeters as a bit of a distraction. I don't need to know the length of the rectangle because I don't know the width of the rectangle. So I'm just going to do it all with fractions. If that's 2/5 that's shaded in here, that must be 3/5 that unshaded. And if that's 5/8, that leaves 3/8 unshaded. Now each of these is half of the rectangle overall. So if I want to know what fraction of the rectangle this is, that's 3/5 of 1/2, which is the same as 3/5 times 1/2, 3/10. And unshaded here, that's 3/8 times by a half, 3/8 of a half, which is 3/16. And this is a calculator paper, so I need to add those fractions together. 3/10 plus 3/16, which gives me 39/80 on my calculator. So that's the answer. The unshaded region is 39/80 of the whole region. To check that, I suppose I could do 2/5 of a half plus 5/8 of a half, and that would hopefully lead me to 41/80. What it would do. Question 2. Make W the subject of the formula P equals W minus 3/2. This is a fairly straightforward rearrangement. So multiply both sides by 2 to get rid of that denominator, and that gives me 2P equals W minus 3. Add 3 to both sides. 2P plus 3 equals W. So W is now the subject of the formula. W equals 2P plus 3. Question 3. A, B, and C are 3 service stations on a motorway. AB is 25 miles, BC is 25 miles. Aisha drives along the motorway from A to C. Aisha drives at an average speed of 50 miles per hour from A to B and 60 miles per hour from B to C. So I'm just annotating the drawing as I go. Work out the difference in the time that Aisha takes to drive from A to B and the time Aisha takes to drive from B to C. Give your answer in minutes. Well, I can take a formal standard method with this, but actually the first thing I think to do here is if she's driving at 50 miles per hour for that and it's 25 miles, that means she's going to take half an hour. It would take her an hour at that speed to go 50 miles. She's only going to go half. So she's going to travel 50 miles in an hour, 25 miles in 30 minutes, half an hour. This one, she's travelling at 60 miles per hour. That means she's travelling a mile a minute. So to cover 25 miles is going to take her 25 minutes, meaning the difference in time is 5 minutes. If I was going to use a more formal method there, I would say that if speed equals distance over time, and I need to know difference in time, I'll look at time equals distance over speed. So for the first bit, time equals 25 over 50. And for the second bit, t equals 25 over 60. 25 over 50 is half an hour. And 25 over 60 is 5/12 of an hour, which if I multiply that by 60, to get it in minutes is 25 minutes again. So 30 minutes, 25 minutes. And then I've got those 2 times ready to compare. So difference between A to B and B to C is 5 minutes. Question 4. Solve the simultaneous equations. 4x plus 3y equals minus 7. 3x minus 4y equals 26. I have to have either the same number of x's or the same number of y's. For this one, I'm going to get it in a position where I have the same number of y's so that I can add this equation to this one and eliminate the y's. So I'm going to take this first equation, equation 1, and multiply it by 4 so that I end up with 12y. That gives me 16x plus 12y equals minus 28. And I'm going to take this equation, equation 2, and I'm going to multiply it by 3 again so that I end up with minus 12y. So that's 9x minus 12y, and 3 26's is 78. And then I'm going to add these equations together, and that gives me 25x equals, because 12y added to minus 12y is 0, 78 minus 28 is 50, so x equals 2 when I divide both sides by 25 there. X equals 2. I now need to go back to my original equation, so sub into 1. X is 2, so 4 times 2 plus 3y equals minus 7, so y must be a negative number here. That's 8 plus 3y equals minus 7. Subtract 8 from both sides, and that gives me 3y equals minus 15. Divide by 3, and y equals minus 5. So I've got my two answers, and of course I want to check that because it's one of the questions that I can check simultaneous equations. So checking this, sub into equation 2, the equation I haven't used so far. So 3x, 3 times 2, minus 4 times minus 5 equals 26. That is 6 minus minus 20 equals 26. 6 plus 20 equals 26, which is true. So I've got my answers correct. X equals 2 and y equals minus 5. Question 5. Toby invested £4,500 for 2 years in a savings account. He was paid 4% per annum compound interest. How much did Toby have in his savings account after 2 years? The easiest way to do this, the quickest way with a calculator, the original £4,500 times by 1.04, which is an increase of 4% per annum, squared because it's 2 years. Which gives me 4867.2. Another way to do that, if you were going the slow method, would be to say 4% of 4,500 is £180. So after 1 year, you'd have £4,680. 4% of 4,680. Find out what the 4% of 4,680 is and add it to that, and you'll end up also with 4867.2, which should be written as £20, because that's how we write pounds and pence. Jasper invested £2,400 for n years in a saving account. He was paid 7.5% per annum compound interest. At the end of n years, he had that much, £3,445.51 in the savings account. Work out the value of n. Well, for this one, after 1 year, he's going to have 2,400 times by 1.075. It's not 1.75. That would be a 75% increase. People often make a mistake with that. So 7.5%, the 7 is the bit that goes here, 1.075. Which is 2,580. And I can just keep going year by year. So that's after 1 year. 2 years, times by 1.075 again. That previous answer, that's 2773.5. And I can keep on going like that. 1.075, 3 years, 298, 1.5, 4 years, 3205.1, getting a bit closer. 5 years, 3445.510. So that's it after 5 years. N equals 5, it's after 5 years. I could also have looked at that whole situation with setting up an equation, which might not be the first thing that people want to do with this, but if I have 2,400 times by 1.075 to the power of n, because it's happening for n years, that would be £3,445.51. If I divide both sides by 2,400, and that leaves me with 1.075 to the power of n equals 1.4356, etc. I would then, at this level of maths, at GCSE level maths, I would then keep on just multiplying 1.075 by itself until I got to this number here, and that happens when n equals 5. So 5 times itself gives me that number there. Question 6, here is a shape. BPC is a semicircle. BAC is a right angle triangle. BC equals 8 centimeters, AB equals 5 centimeters. Work out the perimeter of the shape. Give your answer correct to 3 significant figures. So we've got 2 unknown things to work out here. We've got this arc length here, which is a semicircle, and we've got this straight line, which is part of a right angle triangle, so I can use Pythagoras for that. So I'm going to call this one x and work out what that is. Using Pythagoras' theorem, x squared equals 8 squared minus 5 squared. That's because 8 is the hypotenuse opposite the right angle. It's the longest side. So x squared equals 8 squared minus 5 squared. X squared equals 64 minus 25. X squared equals 39. So x equals the square root of 39, which equals 6.24499, etc. So that is this length AC. Semicircle. Well, the circumference of a circle is given by pi d, pi times the diameter, and semicircle is going to be half of pi d. So that's half times pi times by diameter, which is 8. So that's 4 pi, which on my calculator is 4 times pi equals 12.56637. Perimeter. My answer needs to be to 3 significant figures, so I'm just going to add my answers to 5 significant figures to make sure I'm going to round correctly in the end. I've got this BPC, which is 12.566. 56637 plus 6.24499, which is this length here, x, plus 5, the remaining side of the triangle, and that equals 23.8113606. So to 3 significant figures, I just look at the first 3 digits here, 2, 3.8. And I don't need to round up because it's a 1 afterwards, so 23.8 centimeters is the perimeter. Question 7. The diagram shows a trapezium, x plus 6, 3x minus 4 and x minus 1. All measurements on the diagram are in centimetres and the area of the trapezium is 119 centimetres squared. Show that 2x squared minus x minus 120 equals 0. So for this, there's obviously some relationship between area and these measurements given here. So I'm just going to work through this forwards as if I had to come up with an expression for the area of this trapezium. So normally on a trapezium, our formula, we've got two parallel sides, A and B, and its height, and the area equals A plus B, the average of those two parallel sides, over 2, A plus B over 2, times by the height. So in this case, we've got area equals A plus B is x plus 6 plus 3x minus 4 all over 2 multiplied by the height x minus 1. And that equals 119, that is the area. So collecting like terms there, x plus 3x is 4x, plus 6 minus 4 is plus 2 over 2 times by x minus 1 equals 119. And I can divide each of those by 2, so 4x plus 2 divided by 2 is the same as 2x plus 1, multiplied by x minus 1 is 119. Expanding those double brackets, we've got firsts, outsides, insides, lasts. Firsts, 2x times x is 2x squared. Outsides, minus 1 times 2x is minus 2x. Insides, plus x, and lasts, minus 1 equals 119. And now I look at where I'm trying to get to with my answer, show that that is that's set equal to 0. So in order to get this equal to 0, I need to subtract 119 from both sides. 2x squared minus 2x plus x, that's the same as 2x squared minus x. Minus 1 minus 119, that's minus 120 equals 0, and that's my answer there. Because it's a show that question, each stage of this needs to be shown clearly where it needs to be possible to read it logically from step to step. Find the value of x, show you're working clearly. So that's basically asking me to solve this equation here. 2x squared minus x minus 120 equals 0. So that presumably factorizes into something with a 2x and an x. Seeing as this is the calculator paper and I haven't spotted the numbers that work here yet, I'm just going to use the quadratic formula. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And a is 2 in this instance, b is minus 1, and c is minus 120. So x equals minus minus 1 is the same as plus 1, plus or minus the square root of b squared is minus 1 squared, minus 4 times by a, 2, times by c, minus 120. All over 2 times a, 2 times 2. So x equals 1 plus or minus the square root of 1 plus, because minus 4 times minus 120 gives you a positive answer, 4 times 120 times by 2 is 960 over 4, which is the same as 1 plus or minus square root of 961 over 4. So that is 1 plus or minus 31, that's the square root of 961 over 4, which is either 32 over 4 or minus 30 over 4, which is 8 or minus 7.5. But if it's minus 7.5, we can ignore that answer, because if I look at x here, x has to be a positive. Well, these lengths have to be positive. So if x was minus 7.5, that length and that length and that length would all be negative. So I can ignore the minus 7.5. It is part of my solution of the equation, but it isn't a possible value of x. In the mark scheme, it doesn't matter if you leave the minus 7.5 in there, but it's not actually a possible value of the x in the diagram. Just looking at this factorizing, if it's 8 or minus 7.5, that must have been 2x plus 15. That's where the minus 7.5 goes in there, and x minus 8, telling you that x equals minus 15 over 2, which is the minus 7.5, or x equals 8. Well done if you spotted that, and that's the way you did it. Or if you use the formal method for factorizing when the coefficient of x squared is more than 1, when you've got more than 1x squared. This is a really good, quick method if you're able to spot it, and the reason I just went to this method is because it didn't come to me quickly, so I thought it would be quicker and surer to use this method instead. Question 8, here is a number line. Write down the inequality shown on the number line. So x is obviously to the right of, so greater than minus 1, and because it's shaded in here, that means it's greater than or equal to minus 1. The minus 1's included. If it had been open, it just would have been x is greater than minus 1. P is an integer, and P is between minus 5 and minus 2, not including minus 5. Integer is a whole number. Write down all the possible values of P. Well, it can't be minus 5 because it's greater than minus 5, so the next one is minus 4, minus 3, and minus 2, which it can be because it's or equal to. And part C, solve 5y minus 2 is less than 18. So solve this like an ordinary equation, add 2 to both sides to get the 5y on its own. That's 5y is less than 20, and divide by 5. Y is less than 4, and that's just a straightforward inequality solution there. Question 9. There are 9 counters in a bag. There's a number on each counter. Cal takes at random 3 counters from the bag. He adds together the numbers on the 3 counters to get his total. So whichever he draws, he adds together to get his total. Work out the probability that his total is 6. So normally I would approach this kind of question with a sample space diagram showing all the possible outcomes. But in this case, it's a bit more difficult because he takes 3 counters rather than 2 from the bag. So my normal sample space table is not going to work in this case. So I'm going to think instead about a tree diagram or possible outcomes that come to 6. He can either get a 1 and a 2 and a 3 in any order, or he could get 2, 2, 2. That would also give him a total of 6. So if I think about the tree diagram, first outcome, second and third, if he gets a 1 first of all, that will have to be followed either by a 2 then a 3, or a 3 then a 2 to get to 6. And we're going to have similar probabilities in all of these. 2 must be followed by a 1 then a 3, or a 3 then a 1. And a 3 would have to be followed by a 1 then a 2, or a 2 then a 1. Probabilities of these first ones, we've got, so probability he chooses a 1 first is 2 out of the 9, 2 out of the 9. Followed by a 2 is 3 out of the remaining 8. And followed by a 3 is 4 out of the remaining 7. And then, in this case, getting a 3 at that point would have been 4 out of 8, and getting a 2 would have been 3 out of 7. And these probabilities are actually going to follow through. If we look at what happens here, if you did this and did the whole diagram in a exam, that would be okay, but it obviously is taking more time than necessary. So if I just look at this first one, probability of getting 1, then 2, then 3, that would be 2/9 times by 3/8 times by 4/7. And probability of getting 1, then 3, then 2 is 2/9 times by 4/8 times by 3/7. And I'm actually always going to get this outcome because it's always going to be a 1 and a 2 and a 3, so it's always going to be a probability of, in the numerator, 2, then 3, then 4, over the decreasing numbers of counters overall, so 9, then 8, then 7. So this would give me the same thing, just in a different order. And that can happen 6 times. And we've also got to consider the one time when we've got 2, 2, 2 as well. So this is 2 times 3 times 4 over 9 times 8 times 7, 504. And we've got 6 lots of that, because it can happen each of these 6 ways. 6 times 24 over 504. Oops. 504 on the denominator is 144 over 504. Probability of getting 2, 2, 2. That would be, first one would be a probability of 3 in 9, followed by a probability of 2 in 8, followed by a probability of 1 in 7. So the probability of getting 2, 2, 2, 3/9 times 2/8 times 1/7 is 1 in 84 chance of getting 2, 2, 2. So the overall probability of getting a 6 in total is these 6 times added to that 1 time. So 144 over 504 plus 1 over 84 and that is 25 over 84. So that's our final result. All the probabilities added together, 25 over 84. There are almost definitely some other ways of thinking about that and going about that. Some would be more long-winded than that. It's fine. It's worth 5 marks, so you could spend 5 minutes on it. More than 5 minutes, in fact, if necessary. But it is quite a complicated question. Question 10. The highest common factor of 140 is x and 20. The lowest common multiple of 140 is x, and x is 420. Find the value of x. So if I break down 140 into its prime factors, that's 14 and 10, which is the same as 2 times 7 times 2 times 5. I don't know what is in x, but if I look at these, the highest common factor of 140 in x is 20. So if this is 140 and this is x, the factors they have in common multiply to 20, which is 2 times 5 times 2. 2, 5, 2. And the remaining factor of 140 is 7. And when I multiply all of these by the number that's missing in here, I would get to 420. So 7 times 2 times 5 times 2, that's 20 times 7 is 140. And what do I need to multiply by that by to get to 420? So 420 divided by 140 is presumably 3. Yep. Which means that the 3 must be in here. So x is a result of multiplying these together. That's 2 times 2 times 3 times 5, which is 60. So x is 60 in that question. There may be other ways of doing that logically, but seeing as I know and use this method, that's the one I'm going for with that one. A number is decreased by 15%. The result is 323. What was the original number? This is the same type of question as the price after a sale. It's an inverse percentages question, working backwards, or reverse percentages. So my number decreased by 15%. 100 minus 15 is 85. So 85% of my original number is 323. My original number times by 0.85 is 323. If I do that in reverse, 323 divided by 0.85 equals missing number, which is 380. And of course, in an exam, I want to check that that's correct. So 380, 15% of 380 is 57, and 380 minus 57 equals 323, so that's correct. Question 12, Venn diagram question. Each student in a group of 32 students was asked the following question. Do you have a desktop computer D, a laptop L, or a tablet T? Their answers showed that 19 students have a desktop computer, 17 have a laptop, 16 have a tablet, 9 have desktop and laptop, 11 desktop and tablet, 7 laptop and tablet, and 5 have all three. Using this information, complete the Venn diagram to show the number of students in each appropriate subset. Subset being the part of the circle that, each region of the Venn diagram. As always with this question, a question like this, the first thing you need to fill in is the central overlap section, where L intersects D intersects T. And that is 5 that have all three, so I put the 5 in there. In this section is people who have laptops and desktops. So laptops and desktops is 9. So if there are 5 of those 9 in there, 4 of them remaining in here. 7 students have both a laptop and a tablet, so laptop and tablet in here, and 7 of them, so 2 goes in here. And then we've got 11 that have both a desktop and a tablet. So 6 to make the 11 in there. Then we look at desktop overall is 19. So in the whole circle of D is 19, so 10 plus 5, 15, which means there are 4 remaining, and now this adds to 19. 17 students have a laptop, 5, 6, 7, 11, and I've got to get to 17, so another 6 in there. And T, we've got 16 with a tablet, 5, 6, 7, added 6 makes 13, and we've got to get to 16, so there are an extra 3 in there. And then of course there's the part outside the circles, people who don't have any of these. We're told that it was 32 people in total. So in order to work out how many are left outside, I've got 32, well let's add all of these together, 4 plus 4 plus 6 plus 6 is 20, plus 5 plus 2 plus 3 equals 25, 6, 7 equals 30. 32 minus 30 is 2, so the remaining people here are 2. So all sections are filled in there for 3 marks. One of the students with both a desktop computer and a laptop is chosen at random. So desktop computer and a laptop is this region here. There are 9 of those people. And the question says, find the probability that this student also has a tablet. So out of those 9 people, 5 of them have a tablet. So the probability of them having a tablet, after seeing as that they're being chosen out of that very small subset of people, people who have both a desktop computer and a laptop, is 5 out of 9. The The function f is defined as f of x equals x minus 6 over 2. Find f of 8. So f of 8 is, I just replace the x with the 8. 8 minus 6 over 2 is 2 over 2, which equals 1. Express the inverse function f to the minus 1 in the form f to the minus 1 of x equals. So, in this, I think about what's happened to the x. X, when I did the function of x, I subtracted 6 to get x minus 6, and then I divided by 2 to get x minus 6 over 2. So working backwards, start with my x, multiply it by 2, and that will get me to 2x, doing the inverse operation to each one. And then, instead of subtracting 6, I add 6, which gives me to 2x plus 6. So the inverse function is 2x plus 6. And to check that that works, I'll take a value of x, a simple value of x, let's say 6, because it's going to be subtracted from that, or 0, I'll take 0, and just check, say f of 0 equals 0 minus 6 over 2, minus 6 over 2 is minus 3. F to the minus 1 of minus 3, if I do that, that is 2 times minus 3 is minus 6, plus 6 is 0, so it works. My inverse function leads me back to the original input. I could have also tested that with this here. If I put 1 into this, 2 times 1 is 2, plus 6 gets me to 8, which is what I put into that one. So that's a good check that you've got your inverse function correct. The function g is defined as g of x equals the square root of x minus 4. Express the function g of f in the form g of f of x equals, and give your answer as simply as possible. So g of f of x means that I need to put the function f of x into g of x. So g of f of x is the square root of f of x minus 4, which is the square root of, if I look at f of x itself, x minus 6 over 2 minus 4. I suppose to simplify that, I can put it all over 2 as s minus 6 over 2 minus 8 over 2, which is the square root of x minus 14 over 2. And that's as simple as I can go. Question 14. The diagram shows a prism. The triangle PQR is a cross-section of the prism, so that triangle follows the whole way through the prism. PR is 20 centimeters, MP is 12 centimeters. These are parallel because it's a prism, even though they don't look it in the diagram. PRQ is 30 degrees, that angle here, and PQR is 90 degrees as shown on the diagram. Calculate the size of the angle that the line MR makes with the plane RQLN. So RQLN is this sort of base of the prism here, and the line MR is that one there. In order to find this angle, I actually need to mark in a line here. We're talking about the angle between the line and the plane, so we're talking about this angle in here. That's the one I'm looking for. It's not the angle between the line and the front of the prism, or that angle and any other angle. It's just between that line and that whole plane surface. So give your answer correct to 1 decimal place. So in order to do that, I'm going to need to know the length of line MR. This is a prism, so that is a right angle there. So all the faces in a prism are rectangles. So that's going to enable me to work out MR using Pythagoras' theorem. I'm going to be able to work out ML because ML will be the same as PQ, and I can work that out using this line and this angle using right angle triangle trigonometry ratios, trigonometric ratios. And once I've got that and that length, I'm going to be able to work out x also using trigonometric ratios. So first of all, MR squared is the hypotenuse, so that is 12 squared plus 20 squared, which is 544, I think. Yep. So MR is the square root of that, which isn't an exact answer, so I'm going to leave it as root 544 at the moment. I know that it's 23 on my calculator, 23.32380. And I'm going to use it to that number, that degree of accuracy in my further calculations. 23.32380. Or in fact, I might just use root 544 in my later calculations. PQ, if I look at this triangle here, PQR, 30 degrees and 20, that means I've got a hypotenuse and I've got the angle here, and I'm looking for the opposite side, O. So I've got hypotenuse and opposite, so I'm using sine. Sine 30 equals opposite over hypotenuse. So opposite, which is PQ, is 20 sine 30. Sine 30 is a half, so 20 times a half is 10. So PQ is 10 centimeters, which means that ML is also 10 centimeters, because it's equal to PQ. It actually doesn't tell me to show all working here, so although I'm writing down the details of where everything's coming from, that won't necessarily be required for the marks, as long as I get the right answer. But at the same time, in order to help get the right answer, it's good to have everything written down and to annotate the diagram as you go. So this leads me to my final triangle, which is RLM, right angle triangle. I know that this height ML is 10, and I know that this length here is root 544, and I'm looking for this angle x in here. So again, I've got opposite hypotenuse. Haven't had to use the adjacent at all. So sine x equals opposite over hypotenuse, which is 10 over root 544. So angle x is inverse sine, sine to the minus 1 of 10 over root 544. So on my calculator, I'm going to do square root 544, 10 divided by that answer, and then press shift sine to the minus 1 of that answer, and that gives me 25.38803, and I need to give my answer correct to one decimal place, so that is 25.4 degrees. And looking at that picture, 25.4 degrees, I can't tell whether it's totally right just by looking at the picture, but I can see that it's roughly correct. It should be a very small acute angle, and that's what it is. Question 15. A scientist is studying some rabbits. The rabbits have a disease that kills the rabbits. A population of 160 of these rabbits was reduced to 90 rabbits in 2 days. The rabbit population is decreasing exponentially. Work out how many of the 160 rabbits will still be alive at the end of 7 days. This is a 5-mark question, so there's a lot to work out here. The fact that it's decreasing exponentially means it's the amount that it's decreasing by is constant as a multiple. So it means that, so for example, at the start there are 160. If I multiply this by whatever unknown number it is, a constant ratio between each days, it's happening 2 days in a row, that will give me 90 rabbits. So my x value here, because it's decreasing, I'm looking for some value of x which is less than 1, some fraction. So if this is true, if I rewrite this algebraically, 160x squared is 90. So divide both sides by 160. Gives me x squared is 90 over 160. which is the same as 9 over 16. So if x squared is 9 over 16, that tells me that x equals the square root of 9 over 16, which is root 9 over root 16 using laws of surds, which is 3/4. Root 9, root 16. That would happen if you did that on your calculator as well. So x equals 3/4. Now we use that to say how many of the 160 rabbits will be alive at the end of the 7 days. So at the start, and we should always lay this out in a table clearly, start 160 rabbits. Day 1, we've got 160 times by 3/4. So 120 rabbits left. Day 2, we've got 120 times by 3/4, or let's say 160 times by 3/4 squared, which gives us 90. Obviously, that's already what we've been given in the question. Day 3 will follow on 160 times 3/4. I'm going to call it 0.75, just for ease of writing, cubed. Day 4, again, same type of thing. When it gets to day 7, we've got 160 times by 0.75 to the power of 7. So 0.75 to the power of 7 is 0.133. If I multiply that by 160, I get 21.357, which to the nearest rabbit, because we're working out how many rabbits will still be alive at the end of 7 days, to the nearest rabbit, that is 21 rabbits, although I expect the mark scheme will also allow 22 coming from that value, because although it's not the nearest whole number, it is a whole number of rabbits that is close to that number. So either 21 or 22 rabbits remaining. Question 16. Work out the area of the quadrilateral ABCD. Give your answer correct to 3 significant figures. This is, I can see a right angle triangle here, so if I can work out AC, then I'll be able to do half the base times the perpendicular height and get the area of ABC. And this triangle, I can find the area using half AB sine C. So let's get that first of all. Triangle ADC, area equals half times AB sine C. That's half times 7.4 times 11.8. They're interchangeable. They're either side of the angle, which is why I can use this formula, times by sine 132. So on my calculator, sine 132 times by 11.8 times by 7.4, and divide that answer by 2, gives me 8.0845. Just going to double check that. No, I made a mistake in my calculations there, so ignore that. It seemed very small, which is why I checked. I thought an area of 8, given those dimensions, seemed very small. So I checked it, and actually the answer should have been 32.4457. So it's always worth checking to see if your answers are reasonable or not. Because I made a mistake, I then check it one more time. Sine 132 times by 11.8 times by 7.4 divided by 2, and again 32.4457. So I've put it down to a few, 6 significant figures there. My answer will have to be to 3, but I'm just keeping the detail and the accuracy in here until the final stages. In order to find this length here, I'm going to need to use the cosine rule, because I have 2 sides of this triangle and an angle in between them, which means I can use that cosine rule. Cosine rule is a squared equals b squared plus c squared, like Pythagoras' theorem, but minus 2bc cos a. So in this case, my a side, the side opposite the angle, is AC. So AC squared equals 7.4 squared plus 11.8 squared minus 2 times 7.4 times 11.8 times by cos 132. So I'm just going to work this out stage by stage. 7.4 squared plus 11.8 squared is 194 minus, so cos 132 is minus 0.66, so I've got to be aware of the negative number as I do this. Multiply it by 1.8, multiply the answer by 7.4, multiply the answer by 2, and that is minus 116.8569. Got that number in my calculator, so on my calculator I'm just going to put 194 minus the answer, knowing that I'm expecting an answer to be about 3 or 400, because that will be, that minus makes it a plus. I don't know where I got 400 from. It's around 300, that's correct. 310.8569. That's AC squared. Looking at that diagram, AC has got to be roughly around, I'd say, anywhere between 15 and 20 centimeters, just looking at these dimensions here. So AC equals the square root of 310.8569 ... still in my calculator. So root answer, square root of the answer, AC equals 17.631. So that there is 17.631. Area of that triangle, of triangle ABC, equals half times 17.631 ... still in my calculator, times by 8.2, and that equals 72.28765. So total area is my original triangle added to that. Total area 32.4457 plus 72.28765, which equals 104.73335. And the three significant figures, I just need the first 3 digits there. And because that 4 is followed by a 7, I need to round it up. So the total area is 105 centimeters squared to 3 significant figures.